Hello, I'm Professor Rachael James from the School of Ocean and Earth Science. I teach students in marine biology, oceanography, and geology, and I also do research, and I want to talk to you today about some of my research interests. So what I'm going to talk to you today about is about how can we remove carbon dioxide from the atmosphere. I'm sure you're all aware that we've added lots of carbon dioxide to the atmosphere since the Industrial Revolution, from burning of fossil fuels, from cement manufacture, and even from drink bottles like this. So why do we want to remove carbon dioxide from the atmosphere? As I'm sure you all know, the high levels of carbon dioxide have led to global warming, and this has increased the frequency of extreme events such as flooding. It's led to sea level rise, and it's causing problems with shifts in agriculture and also warming of the oceans. So how are we going to take carbon dioxide out of the atmosphere? Well, of course, the principal thing we want to do is to stop emissions in the first place, stop that carbon dioxide getting into the atmosphere. But unfortunately, that's not going to be enough. And what we now need to do is actively take out carbon dioxide from the atmosphere. And this is what we mean by negative emissions. So where do the oceans come into this? Well, the oceans are by far the biggest store of carbon dioxide on our planet. So the purpose of my research is to figure out ways to encourage the oceans to suck up more of that atmospheric carbon dioxide. So one way we can do this is to use the primary organisms that live in the ocean, the algae, that take carbon dioxide from the atmosphere and turn it into organic carbon. Now, it turns out that in certain parts of the ocean, the growth of these algae is limited by a lack of iron. So some of the research that I've been doing is looking at ways of adding iron to seawater to increase the productivity of those phytoplankton and therefore take more carbon dioxide out of the atmosphere. And this is a really successful technique, but it's not successful everywhere because as those phytoplankton die and decompose, they can re-release the carbon dioxide back to the atmosphere. So it turns out that the best parts of the ocean to do this in are places where we can bury those decomposing phytoplankton really, really quickly. So we need to bury those bodies really quickly. Something else I've been doing is looking at applying crushed up rock, particularly basalt, to agricultural crops to increase removal of carbon dioxide. Now you might be wondering what's the link between this and carbon dioxide in the oceans. And the link is that carbon dioxide from the atmosphere that dissolves into rainwater, it reacts with rocks on the Earth's surface, with soils on the Earth's surface, and ends up in the ocean. And when it's in the ocean, it's securely stored on timescales of tens to thousands of years. So one of the other research projects I'm doing is looking to spread crushed up rock onto land to increase the rate of this reaction. And again, it turns out that this is a really good way of removing carbon dioxide from the atmosphere. But some of the potential side effects of that are areas of research. So, for example, the basalts can contain relatively high levels of heavy metals. And so we're looking to see if this could cause an issue with water quality. And then the final area of research that I want to talk to you about today concerns work done on one of our most beautiful oceanscapes. These are mangroves, mangrove and seagrass beds. Now, what mangroves and seagrasses do is that, again, they take carbon dioxide out of the atmosphere and they convert it into their own biomass, or this so-called blue carbon. But unfortunately, due to fishing pressures, population growth, lots of mangrove and seagrass beds have fallen apart over recent years. So what we're looking to do is to restore these coastal habitats, and our research is showing that if we do this, it can actually be more effective for removing carbon dioxide than reforestation. So summing up what we're doing, the critical thing here is that these negative emissions, taking carbon dioxide out of the atmosphere, is going to be an essential part of mitigating the impacts of global warming that needs to be done at a big scale by about 2030 to 2050. So in Southampton, we're working to find solutions for this, and our students are assisting us with it.